What's going on, guys? This will be a kind of a shorter video, but hopefully you learned something. I'm here today. I got a call that this system wasn't working. Show up. I've already got it reset, but the error code on that LED display was 4250, which is most of the time a failed compressor or a shorted compressor. When you get a 4250, you have to hook up to the system and you can pull in the error code and get what's called the detail code. So that 4250 can have multiple different causes and you have to figure out what the detail code is to get that. So hooking up just like normal, going to the malfunction log, pulling in the error log for this system, and you can see it was 4250 with a detail code of say 106, which is instantaneous overcurrent. So that says as soon as your inverter board sent power to the compressor, it instantly saw the compressor pull too many amps. So that could mean that it's shorted, it can mean that it's locked up, many different things. Could be a bad inverter board. So you've got a 4250, you come over, this is the unit that was having it specifically. So came over, pulled the wiring off the compressor, tested the compressor to ground, and it was grounded on all three legs. One thing you have to be careful of when you have that error code, you have to pull, if it has insulation on it like this one does, most of them don't, but you have to feel the compressor, feel it just with your hand, make sure it's not ice cold, make sure there's no liquid inside the compressor. If there's liquid inside the compressor, so much so that it goes up and fills those scrolls up, I've had it to where the compressor will pull LRA because it's so full of liquid. I've also had it show continuity to ground, again because it's so full of liquid. You have to drive that liquid out. It takes forever, but you can get a heat gun, put it on that compressor, and just drive that liquid out of there. Once it's out of there, then you have to figure out, well, what caused that compressor to fill up with liquid. If that compressor fills up with liquid, that tells you that that accumulator is likely full of liquid. If that accumulator is full of liquid, you've got serious problems because that thing can hold a lot of refrigerant. So this system is twinned to the one next to it, just over there. So this one has a failed compressor, it's grounded. The one next to it does not. This compressor is fine. So why can we not have a system with one failed compressor but have a good other compressor just run until we can get this compressor replaced? So what we can do is shut the system with the bad compressor off, close the ball valves, it's very important, close both ball valves, shut the power off, turn this one on, this one will take over and do the best it can, because again you're down half your unit. In this case we're down 120,000 BTUs, but we've still got a good compressor. This one can do what it can to maintain set point. It does quite well actually too. So the reason we want to close those ball valves is because again they're piped together. This system will push refrigerant into this unit and it will fill it full of refrigerant. Then this one starts to suffer because all the refrigerant's been pushed in there. Then the best part is when you come to recover refrigerant on this unit, it takes you 4 days because this system is totally full of liquid because it's pushed all of that liquid in the system, which is very irritating. So very important, close all those ball valves, shut the power off, turn power off to this unit for a couple minutes or so, turn it back on, and it'll just take off. There's no dip switch settings, there's nothing you need to do in order to tell this unit to run because this compressor has failed. It'll just take off. So one thing I wanted to mention is when you have a failed compressor, it's a very good idea to test the inverter board as well. So you can do what's called a no-load test. There is a jumper, I've already got it pulled out, but on this white connector right there, CN6, you can pull that jumper out. Then what that does is it tells the inverter board, hey, I know you can see the fact that the output is open, but just ignore that and run and pretend like everything is normal. What that allows you to do is then test the voltage on your output of the inverter board. Make sure every leg is within 10% of the other one. Should be very, very, very close. And that'll allow you to verify that the inverter board is working correctly. The last thing you want to do is replace a compressor and realize that the inverter board has failed, or worse, replace a compressor, turn it on, and the inverter board kills the brand new compressor, and now you're out a compressor and an inverter board again. You really don't want that to happen. So the system, this is a water source, so we don't have the same thing, but on an air source, when you do this, the fans will ramp up on the outdoor unit, but the compressor won't start because obviously we've got it disconnected. So that's a good way to tell, okay, it's ready, I can start testing voltage, the fans are on, it thinks it's running. It will report everything, and the system will say, well, I'm trying to maintain a 32-degree TE. Our system pressures are still static at 300 psi on the high and the low side. So it's going to start trying to ramp that compressor up. It's not going to ramp it up because it's disconnected. So it's just going to not do anything. Your pressures aren't going to change because the compressor isn't running. But it is going to start trying and attempting to, and it's going to freak out, whatever. All you're trying to do is make sure that the voltage output of the inverter board is correct and nothing weird is going on there. So make sure you do that. It's a good habit to get into, and make sure that you only have to make one trip.